Good morning, everyone. Thank you for joining the monthly BRICS seminar. Um, Before we begin, we had like a couple of logistics items. Matt, can we go to the next slide, please? As always, right, with these seminars, we would request you to keep your microphones muted. We don't want to have like any static or any disturbances during the presentation. And as you know, we always record our sessions and we post it on the BRICS site. After the sessions are done, within a week or so, we also send out the thank you emails that has the link for the recordings. So in case you missed or if you want someone else to view it, you can always recommend that link. As always, right, we encourage you to participate, ask questions. So for that, you can always use the Teams chat window for posting the questions. We monitor it throughout the presentation and answer it as we go. We also pause after each presentation and give you time to ask. At that point, right, if you have any questions, you can unmute yourself and raise your question. I think we can go to the next slide, man. So for today's presentation, we have a couple of interesting topics. We will get started with Dr. McAuliffe presenting the CADR updates, followed by Omar Kapoor. He's going to talk about the AI integration work with QueryTool, the POC work that we've been doing and how we'll integrate with the QueryTool. With that, I'm going to hand it off to you, Matt.
All right, good morning. So I'm going to talk a little bit about some of our work with respect to CADRs, which is the Controlled Access Data Repositories, and some of the work that we've been doing to support making sure that we meet those particular requirements. And what's neat about it is that we implement that new functionality within the BRICS platform or framework, and all the instances that are deployed from that framework automatically inherit all that functionality. So we got a very efficient system in supporting the different projects that BRICS supports. But I'll talk more about that in just a minute. First, I just want to give a little bit of background in the BRICS. I know that most people know this here, but for the few that are new to join, I just want to give a quick background of what BRICS is all about. So I've been working here probably on data, making data fair, findable, accessible, interoperable, and reusable, probably for a decade and a half now, even before fair was a term. And that work was involved with NDAR, which was the National Database for Autism Research, which is now part of NDA that's managed over at NIMH. But I've been part of a lot of different working groups, from metrics of repositories to again, making data fair, common data elements work, and all those kind of ideas have filtered into the BRICS platform. And in addition, most recently, security has become an important aspect. BRICS instances are FISMA moderate. We have an ATO that we had to go through the 800 NIST 853 Rev 5, which is the latest revision, and met the FISMA moderate controls. In fact, we probably meet a number of the FISMA high controls, but we have not gone forward with reaching FISMA high, but we've added additional controls to support that. Here's a list of some of the repositories, instances, we call them instances of BRICS, that we support. We have FITBR, which was one of the early ones, PDBP, which is the Parkinson's disease biomarker one. I'm not going to go through all of them. One of the new ones is that we've been working closely with Rebecca Rosen, who is the business owner of DASH, which is the Data and Specimen Hub out of NICHD. And they're now migrating from their the infrastructure they presently have to the BRICS infrastructure. And I think there's a lot of advantages, efficiency advantages of doing that, because we have multiple projects supporting the foundational part of BRICS, and that goes into then each instance of BRICS inherits that functionality. Okay, so this is just just to give you a very broad. We while we support all, making data fair, we support common data elements, we're very strong in supporting clinical research. And we provide an enormous amount of tools that support the different aspects of clinical research as well as kind of regular kind of research and collecting data. We have tools that help collect that data, validate the data. We have protocols for auditing that data. In fact, we're uh, moving on to the next slide. We are 21 CFR Part 11 compliant, which is a requirement that you need to meet to do clinical research. This just highlights the kind of different, broad, very broad scope of the kind of functionality that we support. We can support OMOP, the OMOP data model. We can support FHIR. We've connected to a FHIR server where we can extract data. We're working on a bulk upload of FHIR data into a Bricks instance. We support UMLS concepts. In fact, that's one of our strengths in making data more AI ready. We associate to all our data elements, we associate UMLS concepts, and all the permissible values for those data elements also gets those concepts so that you can programmatically understand the data very efficiently in our systems. In fact, we also use the common data elements to validate the data going into the system. So if you say age, you're submitting age, you have to make sure that it's within a valid age range. So if you tried to submit -5, it would automatically, the validation process would identify that and request that it gets fixed before the submission into the system. We're now starting to add a number of AI functionality. You're going to hear more about that from Omar in a few minutes. We have a PPRL system, privacy preserving record list linkage system. It's called a GUID, and that is harmonized with NDA's GUID. In fact, this goes back to my days in supporting NDAR and developing the PPRL system for NDAR. And so our system, and we have a centralized GUID system now that supports a number of the different institutes. And now that we're also harmonized with the NDA, and we're actually have an active collaboration where we're trying to increase that collaboration at a more programmatic level, programmatic meaning at the programming level, to highlight and to unify that ability to provide PPRLs across a number of different projects. There's an instance of Bricks that's Core Trust Seal certified. We just had it recertified, and that's FITBR. We're also working with NEI and getting their in Bricks instance also Core certified. Okay. So going to CADR. So CADR has been a very hot topic for repositories for the last couple months. And we have been very actively, because our framework supports a number of repositories, we've been very active in making sure that the base part of Bricks meets those CADR requirements, so all the instances of Bricks inherit those controls. So we've already gone through all our repositories instances and made sure that there's no countries of concerns, free or that have access. Any country of concern users no longer have access. If they did have access, we no longer allow free email accounts like Gmail and so forth. So I guess that I skipped a slide here, but that's kind of what we completed for round one back in April. And what we've now done, and we've already completed and deployed, is when you apply for account within a Brick instance, if you have any of that information that is no longer allowed, those free email accounts or addresses, if you're applying from a country of concern or you're on the prohibited user list, it automatically rejects your application and sends out an appropriate email. And we also now audit that information and keep that information within the Bricks logging system. So what we're working on right now is the next level, and the new level is to be able, we have RAS implementation in our system, where our present implementation is we require PIV cards, and that gets you IA level 3. But we also accept login.gov, but login.gov is at IA level 1 at the moment, but we're actively working on upgrading that to level 2. And for international users, we're adding in ID.me into one of the providers. And we expect to have all this in August. And therefore, any instances that are, again, derived from the BRICS framework will get all that new functionality. And we will at that point be and should be CADR um, responsive, I guess, as we would call it. We also work with our collaborators in helping update their DAC information, their charters, their standard operating procedures. So this, again, is a collaboration between us and our collaborators. I do have just a couple moments. I didn't want to take up too much time. I wanted to make sure I give Omar lots of time, but I encourage you to go. We've revamped the BRICS website somewhat. Lots of good information, and I'll point out down here at the far right is the seminar information. And Preeti had mentioned this, is that we update this website and add in the new recordings so you can go back and watch any of the recordings if you weren't able to attend or if you wanted to refresh your memory. But there's also lots of good information. I talked about this is a very comprehensive system. We go all the way from collecting data in our Proforms tool, which is just like REDCap or OpenClinica or any of those other kinds of applications, and it's 21 CFR Part 11, but we have a whole accounts module that's been updated to support CADR. We have our data dictionary that we use to, again, collect the data consistently across the studies. So lots and lots of different kinds of tools. We make those tools available here. One example of a tool is our UMLS mapping tool. This helps us. We build upon the work that was done at NLM. We use their tools and provide some additional functionality that facilitates us being able to quickly or more quickly apply UMLS codes to our data elements. And then that, again, is making our data more understandable at multiple levels. So lots of good information here at this site. This is our PPRL. We show that, we're working with a lot of institutes and providing goods or unique IDs to these different systems. Okay. One of the most important tools within our system is our query tool. It allows you to query over different studies and aggregate that data very quickly because everyone collects the data in a very consistent manner. But now we're adding new functionality to enhance the ability to query and find data within the repository or a repository that you might be associated with, like Fitbird or Parkinson's disease. But with that, I'm going to hand it off to Omar, who is doing a lot of the work on our AI tool that's going to be integrated into the query tool. All right, it's all yours, Omar.
Thanks, Matt. You guys can all see my screen?
Yes. Yeah.
Okay, great. Excuse me. All right. So, yep, we're going to talk now about the AI integration work within the query tool. So that was a great setup and context to kind of talk about what the query tool is. And I'll just, again, give a kind of a quick overview. So as Matt was showing, it's really the part of the BRICS platform that allows users to, it gives them the ability to pull data from the repository, so whichever instance it is where it's deployed at, and to filter that data and then download it based on whatever research question of interest they have. So they're able to access anonymized data, and that data is organized by studies. As Matt was saying, and those studies use form structures, and those form structures consist of the data elements that are, the questions and the things that are recorded by researchers as they're performing their studies, and are organized in form structures. So
Omar,
yeah.
sorry to interrupt. Can you put it in the presentation mode?
Oh yeah, sure.
Thank you.
Sorry, let me just switch. Okay. Can you see? All right.
Yes, thank you.
Okay.
Yeah.
So for power users, the current query tool is working well. So it's, as you can maybe see on the screen there, it provides a way for you to search across forms, search across studies. The search is currently like mainly just keyword search. But for non-power users, it can be a little bit of complicated system. And for data exploration, it can be kind of difficult to find studies or form structures that you're not sure that they exist. And so the goal for this project is for us to integrate AI into this query tool to improve data discovery and to facilitate users being able to find and access data across studies. So you may know of one study, but there may be other interesting studies, other interesting form structures that you want to take into account. So when we look at how we are how we're integrating AI into the query tool, currently the user would come in and they would search for studies. They would go into that keyword search and just kind of iterate through that. But now the way we're building it is that they're going to come in and enter a natural language query. They're still going to have the ability to come in and do the normal searching the way that they would currently. But they can also go to another tab I'll show you some mock-ups towards the end here that is like an AI search tab, and that's where they can just enter a natural language query that goes to an AI process, which is going to take that user query. It's going to search through the metadata, and it's going to find, depending on whether the user is looking for studies or form structures, it's going to find the best results. It's going to return those back with some sort of explanation or context for the user to kind of understand how that study or that form structure relates or maybe doesn't relate to their initial query. And then the user has the ability to kind of, look at that and add the data to their selection and then move through the query tool as it exists to be able to pull that data. So at this point in the process, we're really looking at upgrading the user's capabilities for data discovery and searching and finding useful data within the query tool. So as we're building that process, we kind of have two different environments. And so we have a sandbox proof of concept environment, and that's what I'll be showing you today for a quick demo. So we're just using that for like sort of rapid AI, process development, and we're assessing feasibility and effectiveness. And we're doing that in a quick Streamlit interface, which for those of you who aren't familiar with this, just sort of a fast prototyping framework where you can use Python to quickly get a user interface screen up. And we're just using, truncated data that's just mock metadata, public metadata so it's a very limited very limited number of studies that that we have in that sandbox environment. But we're also at the same time we're preparing and we're moving into Bricks environments. So we're going to be starting with the Fitbird development environment, and we're going to be building it out there to actually implement what you're going to see here in the proof of concept. We're going to be implementing it there, where it'll have access to the full data, and it'll also have it'll be integrated into the web interface, the UI UX that currently exists will be augmented to have the AI functionality. So just as we're looking at productionizing the AI process, and again, that's something that we're still in the development process for. But I just wanted to kind of lay out the things to consider, especially for folks that want to build AI into their products, right? Or in the process of doing that. Just to kind of have that discussion, because it's a bit more complicated than just the simple sandbox that we have for the simple proof of concept that we have in the sandbox. So here to productionize this into the query tool, we have the query tools user interface, which is just your user's browser. That is communicating in the current approach is communicating to a Java layer that's handling data, doing authentication, and so on. We're adding a Python backend, which will be a container. At this point, we're going to be just hosting that on-prem, which is going to be doing the AI components here, and that's sort of what we've been building in Sandbox, and we're moving over now into the development environment. And that's going to be using AWS Bedrock. So within the cloud, that's currently the only cloud service that we have in our architecture. So AWS Bedrock provides inference for your large language models and your embedding models. And then we have our data is stored in Postgres already. And Postgres, you can add an extension, which gives, it's called PG Vector, which effectively makes it into a vector database or gives it that functionality to do semantic search across columns that are designed to be embedding columns. And then you have to also think about if you have this whole process, you also have to keep your data up to date, right? So now you're adding functionality to your system. You need to have the embeddings that you're searching across to do semantic search need to be maintained as your data changes. So we'll have a regular process that collects updates to the form structures and the studies, runs at sort of regular intervals. And it's probably going to be a Java process, but that's going to basically call the embedding model to update the embeddings in the database so that they can stay up to date. Um, all right, so and we can anybody who has questions when I get to that part, I'll try to get through in time for questions. So please, we can jump back to any parts of this if you have them, and feel free to put them in the chat or anything if you feel like you might forget them. But so, okay, so as we're developing this, we're kind of breaking it into incremental phases. So in the first phase, we're really looking at using AI to search and reflect and really build in that data discovery capability that I was just talking about. So that's really focused on providing the user with results and explanations about those results. And I'll go through this graph on the left here in a second. But then phase two, we are going to look at other functionality. And so we've identified some areas where we may want to move into to expand it. So one is sort of conversational search, the ability to say to that the AI agents like, hey, that's not quite what I wanted. I wanted this, or can you add something here? And have it iterate and do the searching and then come back with sort of updated results. Other aspects are that there are things later in the process of getting your data, such as joining forms together and generating filters. And we have in the process of sandboxing and proof of concept development, we have built out the AI to even do those parts of it. But as we were looking at integrating it into the user interface, it made a lot of sense for us to break it into sort of these functional chunks so that it's most aligned to what the user is going to be interacting with and experiencing and kind of needing in that moment. So what we see here in this sort of MVP flow that we've got, and this is again what I'll be demoing here to you in a second. It's going to start with the user query coming in. So we do a quick analyzing of the query. If that query is in scope. So, is it related to NIH? Is it related to public health? Then we're going to go down this path. If it's not in scope, we're just going to go straight to generating an out of scope response. Saves us a lot of compute and token costs here. And it can instead just go to a quick response saying like, hey, we can't actually address this. We also will be adding things like prompt injection, especially as we get closer to productionization. Where we'll detect, does somebody asking it to ignore instructions and things like that. And so if it is in scope, it goes here to parsing the query. This is really where we just take the query, and if you're looking for a study, we parse it into saying like, describe a study that would fit this user query. And that's just really to help with retrieval, optimizing retrieval a little bit. It also allows us to kind of spell things out a little bit more. So if you have acronyms and all, or if you kind of have a very truncated user query, as often we kind of do when we're searching for stuff, it can just expand that a little bit to give better retrieval. And so we're also in this early phase where we're going to have the user select whether it's a form or a study that they want to search for. And that could be something that later we either search for both or we have the AI decide which one are you really looking for. But at least for right now, you'll be able to say, yep, I'm looking for a form. And I'll show you that also in the proof of concept. But they're both fairly similar. So regardless of which one you take, the retrieval process is a semantic search. And I'll talk about that again in a second. The search retrieves a certain number of records. Those go to a review phase where an LLM is going to receive each of those and then basically rank it for relevance against the user's query. And then that's just going to come back to a quick summarization where it'll say like, oh, here's what I found, and also return back all of those things that it did find. And that's all just comes back and it gets then rendered on the user's browser. All right, and so just to talk quickly about when we talk about semantic search, and we don't have to dive too much into this, but basically I've been using the words embeddings, semantic search, right, embedding model. What we're talking about here, embeddings are basically transforming a word or multiple words or maybe even entire documents into just a numerical vector. That's a very sort of high dimensional vector. So like right now we're using the Amazon Titan v2 embedding model because we're in Bedrock, and that's producing a 1024 dimensional vector. So for example, for every study we take, the title, we take the UMLS concepts, we take the abstract, and we can turn that into just a big vector of numbers, right? 1024 numbers that describes that piece of text. And what this allows us to do is really compare any two pieces of text to see how similar they are. And embeddings are really like sort of like one of the lifebloods of large language models and generative AI, right? And so this is actually like how partly how like language models are able to do so well because they're working, in a quantifiable semantic space sort of underneath the hood. And so we can use this to basically then give us semantic search. So if we take a user's query and we have this embedding data set of all of the studies, right? And we take a user's query about what studies they're looking for. We turn that into a vector using the same embedding model that we've created for all the studies. And then it's just a quick, basically similarity search, right, between vectors of numbers to see like, okay, which studies are closest semantically to this search. And that allows us to be much better than a keyword search. So a keyword search is going to look for matches on specific words, right? Or maybe stems of words, but like it's only going to return things that are like, actually sort of, share the same words in them. And so you might have studies with abstracts that are describing the same concept, or the relevant concept, but they don't use all the relevant words, or maybe none of the relevant words, and you still want to be able to find that. And so that's sort of what semantic search really allows you to do by mapping things into this multidimensional space. All right. So I'm sorry, just a little sidetrack there. So we'll jump into the demo now. So just to give you a quick overview of the tech stack. So we're for the AI backend language, we're using Python. For the framework, we're using LangChain and LangGraph, which is an open source framework that's available for Python and JavaScript. Excuse me. That allows you to just sort of facilitates, the execution of calling the LLMs, calling the embedding models, the vector database, and stuff like that. And for the vector database, we're planning on using Postgres. I'm actually, for the proof of concept, I'm still using an open source vector database called ChromaDB, but we are going to be switching even the sandbox over to Postgres here soon. And obviously, once we're in the development environment, we'll be using Postgres. We're using AWS Bedrock again for model inference. For the LLMs, we've been using the Claude family from Anthropic. Those are some of the highest performing models on Bedrock, but there are others as well. And so that's something that we also want to test out moving forward is some of the other model families. And again, just the Titan v2 embedding model. There's not a lot of different embedding models on Bedrock, but this one is perfectly fine. And again, we're using Streamlit for the interface. So let me just bring this up quickly.
Just a moment, Omar.
Sure.
There are a couple of questions that I think you could help answer. So we have one from, I don't know if you can see the chat. If not, I can read it. Which would you like?
Sure. Yeah, I can see it. Okay. Yes. Oh, wow. A lot of questions. Okay. Yes. Yeah, so we're gonna do the demo now. And the content being searched is, so we're searching against the metadata that we have in, so if you, for example, let me bring this over here. If you say you want to search form structures, right, then your search query is going to be basically against all the form structure metadata, right? So for that, we have the form structure titles, we have the form structure descriptions, And all of those have had embeddings created for them, and then that allows us, and they're prepared already in the vector database, right? So that allows us to just execute the semantic search. And the technology, oh, I see you guys are answering some of these. The technology doing the analyze query and parse query is lang graph and sort of lang chain as well. And that's really like this open source framework that's available for Python and JavaScript that, but really it's Python at the end of the, in the back end that's doing it. And yeah, so we're using LLM wise, we're using my favorite one is Claude 3.5 Haiku right now because it's smart and it's small and it's cheaper. And so for a lot of the testing stuff, Claude 3.5 Haiku is great. Obviously, 3.7 Sonnet is the latest Claude model, but we've got a bunch in here, and that's part of building the system as well. Is obviously once we integrate it into the actual environment, we're not going to give the user the ability to pick the model. That'll just be set. But while we're in a sandbox, it is useful to just test different models. And you obviously want to find the smallest model you can that's going to be, fast and cost efficient, but also going to be good at doing some of the reasoning, because there is real reasoning here, right? You've got to take for example, for every form structure you find in this search, you've got to analyze the user's query against that form structure. And that's well, we can talk about that a little bit. I'm happy to geek out on some of this, but like that's basically the reasoning step here that's super valuable. One of the reasoning steps that's super valuable. And requires the LLM to actually really like put some thought. So some similarity, not really a semantic search. So I don't know, we can get into that. It's semantic search in the sense that the embeddings are putting all of these into this multi-dimensional space. Whether you want to, it is a similarity search, it's a distance search, but it's semantically in terms of saying like, what does that space represent? The embedding models are sort of trying to get at semantic meaning, right? So when we say semantic search, it's just sort of an industry term that's used. It is similarity, you're right. And it's actually an approximate, basically an approximate nearest neighbors algorithm. In this case, we're using hierarchical navigable small worlds that goes in and sort of finds a subset of the vector database, and then from there it is just a distance metric. I'm using Euclidean distance here. You can use cosine. You can use a bunch of different distance metrics. But yes, so it is both actually. It's kind of splitting hairs. And yeah, so there's other questions here, if I should just get into the demo. Yeah, 3.7 is great for reasoning purposes. Yeah, absolutely. It is more expensive though. And so that's a trade-off, right? And that's where you want to kind of find that balance as well. So, okay, so this is the proof of concept. It's just a very rough streamlet. So again, we can select which model we want. We'll go with Haiku because it's fast. We can select whether we want to search across form structures and studies. And again, that's sort of, at this point, it's a user input. And then if I search for, let's say, anxiety in elderly patients with body pain, and I submit that, it's going to go through each step. So as you saw in those nodes, it's checking the query for in scope, parsing it. Now it's retrieving forms from that metadata database. And then what it's going to do is, and hopefully it'll work. And then it's going to be reviewing those forms and then come back with basically a summary. And this right now is taking about 30 seconds. And so that's something obviously where, if you use a bigger model, it may do a better job, but it also is going to take longer. And there's little things like that we can do to also continue speeding this up. For example, the review process is a little bit slow because I'm doing it sort of linearly right now. But that's something where we can we'll probably refactor that into a batch execution. But again, we also have to just manage costs and token costs and stuff like that. So we want to kind of be monitoring that. So okay, what we found was, let me make this a little bigger so you guys can see. Okay, so we have over here like a little summary, right? So the results, it found 4 form structures related to the query, 2 highly relevant results. So this one is probably the one we would want to choose. GAD7 is a very common form structure used for assessing anxiety symptoms. Another one that's a strong one is BSI 18. Brief Systems Inventory includes an anxiety subscale, offers a global view of psychological distress, and then it found some other ones, that the user may be interested in, but they're not quite as relevant. And over here, we can see the search results, right? So we've got GAD7, and I just did, for the proof of concept, we've got some quick color coding here. Excuse me. So here we can see this is what it searched across, right? So we have a form description, right? So this is basically what we have in the metadata for this form structure in the database, right? And this is a big part of what it searched on semantically, right? For a similarity comparison between this query that came in, right, and these the descriptions. And then we have we have a relevance score. We haven't quite decided if we're going to be pushing that to the front end or if we're just going to categorize, but I'm having it assign a relevance score from 0 to 5 as part of that review process, because that's sort of just a nice way to classify. So it gets a little bit of prompt instruction to say like, okay, classify, as a 0 or a 1 if it's totally not relevant, two or 3 if it is partially relevant, and 4 or 5 if it's like extremely or highly relevant, right? And so that score is kind of just at this point, just a sort of filtration thing. That's what the color coding is based off of. But one of the main things that we really want to use is the reason here, right? And so you want to get kind of a quick breakdown. Oh, okay, this is relevant to me because, XYZ. And so this is kind of what I'll show you in a moment with the UI. Like one of the things we're going to push back and have the user kind of have easy access to. And so we have this for, for each one of these, right? And so if we go to the geriatric depression form, this one got a lower score of a 3, still potentially relevant. And you can see from the reason here that, while it's focused on elderly mental health, it's primarily assessing depression rather than anxiety. And so that's good to know, right? So the user may be interested in that. It's possible, but based on their query, maybe not. So that comes back for each of the results. And, in some cases we have like this one got a 0 and it's preclinical animal history. So this is, and again, I also don't have the full data set as I was saying, right? So this is just a very truncated data set. So I can't really kind of ask it any sort of questions because I may not have that data in there. And we can ask the question, but it may not be able to retrieve anything. And so, so some of this is going to be really important for us to continue testing in that development environment where we're going to have the ops team coming in to use it and evaluate it. And we can also continue to tweak prompts, right? So that's a really easy way for us to continue sort of ratcheting the underlying, AI backend to just give better results for what people are really looking for by sort of just prompt engineering and tweaking those prompts. And there's other things as well. One of the things I've been working on, which I don't quite have in here, it's still kind of I'm still workshopping it, is like a dynamic search. So currently in that vector database, we're just going out and saying like, give us the 5 closest results back, right? And if you think about the way that similarity search, semantic search is happening, right? Like you're saying like, okay, take some user query and put it into this, semantic multidimensional space, and then find the ones that are closest to it, right? But from there, you still have to do reasoning. And semantically, it's not like everything is guaranteed. If it's close, it's guaranteed to sort of be a great result. You still need that reasoning approach. But one of the things we're looking at is a dynamic search, right? So that we can say, if you, for example, have 10 really good responses or 10 really good form structures, let's say, right, for whatever you're looking for, then you want to find 10 and not just 5, right? So a way for us to dynamically increase that And if I start going into that, I will probably take up the rest of our time. So I'm going to quickly just jump back here, and we can always jump back to the demo. Oops. To just the UI mockup so that you guys can see. And let me get back into this. So just so you can see what at this point we've got. This will. Oh, here we go. So this is how we're looking to build it in. And I just have these in slides for kind of easy access here. But basically, we've got like a description and a search box here. So you've got the search with AI tab, and then you've got the select data tab is already there. That's what exists as the manual approach for going in and finding and selecting your data. And again, that's still going to be there. It's part of the process, at least at this point in our flow design. It's part of the process of getting the data into your cart. So this search with AI, you can choose to begin here if you want. You could, if you're a power user, you know what you're looking for, and you just want to go straight to that, you could just jump to select data and move forward as you might. Already. And so you have a description here where you can put that into the search box. You also have like kind of, you know, some help text, right, about how you can how you should use the AI search. My next thing is not working. Okay. So you enter a natural language query here, right? And then you can hit search with AI. There'll be some like thinking or, you know, sort of intermediary thing. And then what's going to come back, as you saw, you know, in the demo there, is there'll be some results, and the summary will be like, at this point, we're thinking the summary will be on this left-hand side, right? And the user has the ability to give feedback with like a thumbs up, thumbs down, and that'll help us sort of monitor the system and make sure it's doing a good job. And then we'll have like top matches sort of, you know, coming in one part, and then other results or, you know, other potential matches as you saw in the sandbox demo that might be lower than that. You know, you'll be able to expand. This is all sort of placeholder text, but you'll be able to expand the text here to see like that summary sort of text, right? If you want to get sort of that more verbose summary about it. And then you'll be able to click for each match. You'll be able to click on why is this a top match? And what will be populating there is like the reasoning statement, right? So that's, you'll be able to see it specific to the matches. It'll be linked to that in the UI. And so then you'll select from there which ones you want to move forward with. And from there, you can go to the, you'll be able to do that for studies and forms, and you'll be able to go to the select data panel then, or tab, and move forward with it as you normally would. So from there, we have all the functionality built into the query tool to say like, okay, add this to the cart, and then move to the next one to, if you want to make any joins and filter, add any data filters. And this is, again, just kind of the same thing here, and adding, you know, viewing and filtering. Once you've added to the cart, you can do that, and that's just current functionality. And that's pretty much it. So I don't know if we have time for questions. Yeah, we do.
We do have time for questions, Omar. That was just absolutely awesome. I mean, I think I know some of this stuff, and I learned something every time I see your presentation again. So beautiful job. But this does open up the floor for questions for Omar. So one question is, what is the format of the metadata? We're getting it from our database. So those embeddings are from our, you know, common data element, our data dictionary, or our study repository that has that information. And then he feeds that into his Postgres vector. Did I say that right, Omar? Shouldn't have actually answered
Yeah, exactly.
Yeah, that's actually not. Thank you for that, Matt. This is Denise. Can you hear me?
Yes.
Okay.
Yep.
What I really meant was, you know, everybody has a database of this stuff, and I think, you know, I don't know if yours is an Oracle database or what kind of database you have, but are you just taking raw tables and throwing them there? Or are you transforming them into some other format, representation format, like XML or JSON, or like what do you need to use to push that data into your Postgres vector DB and with embeddings?
Yeah.
Is it special?
Yeah, no, it's
CSV
actually
CSV
it's an
files or
extension for Postgres. Yeah, no,
and it,
it's actually just an extension for Postgres. And every product is now coming out with vector database support, or vector support, basically,
oh,
right?
all right. So you're
It's
saying your CDEs and everything are in a Postgres database already, and so it's just a
Yes.
plugin. Oh, okay.
Yeah,
Thank you.
exactly. And so PG Vector allows us to enable a certain type of column, which is like an embedding column, and it gives us the ability to do semantic search across that column.
Okay.
And so you
Thank you.
can build it into your existing thing. There's no need to kind of like totally recreate another vector, data store of a different type or something, and then keep those two in sync and stuff like that.
Right.
So that's one of the reasons we went with the Postgres PG Vector, because we're
Okay.
already using Postgres. Yeah. And then it's really just a matter of saying like, okay, what text do you want to push into your embedding column? And you want to have the
Hmm.
same text, right, for each record. So we're using like we were saying, form title, form structure description, UMLS concepts, and that's something that you can experiment with as well, right? So if you find that your retrieval is not getting the stuff you really want, then maybe, adding certain contexts in. And that's partly why we were looking at things like UMLS concepts and stuff, right? As Matt was saying, to have like a nice, consistent words that are used to describe can definitely be helpful semantically. Another question.
So
Does
I
Brick
can,
hold? Oh, sure. Yep.
yeah, does Brick hold any EHR data? If so, how is the data organized? So the answer is yes. It's de-identified, so we're FISMA monitored, so it has to be all de-identified. And again, we support a PPRL system. But our organization is is essentially centered around the form structures and the data elements. So you can kind of almost think as a form structure as a table within a database, and then all the data elements are those, or the common data elements are the data elements for that table. So it's very flexible. As we build new forms, support for new forms, we don't have to go in and manually update the database. We just automatically build new tables and elements within our system based on the form structures and data elements. I hope that answers your question. Yeah, so this is just to kind of summarize, this has been incredible work that Omar has done. And really what it does is make the data more findable within our system. Like for FIPR, there's over 1,000 different form structures. And we can't expect researchers and over 250 studies. And we can't expect researchers to know exactly which studies and how to find all the data in these different forms and different studies. But his tool will greatly enhance that ability to find those studies and form structures that are of interest. And it kind of, he's been able to kind of blend it into the present system that then allows you to do that final optimization of, I only want subjects from, 30 to 45 who are male and so on. While phase two, we're thinking about helping to automate that process too. But for right now, this just goes a long ways in helping to find in this vast database of being able to find the data of interest and be able to query to find your cohort and then get it out. So it's been really great work by Omar and the rest of the team. So it's been much appreciated. Are there any last questions? Before we wrap up, we might be able to wrap up and give you back a couple minutes before the next meeting. But if not, watch the video or reach out to me or anyone else on the team, and we'll be more than happy to provide a demo or go into it a little bit more deeply. So with that, again, thanks everybody. We plan to be very active over the summer. Again, we're doing a lot of work with the CADR. Expect to see that. We're doing some other updates to the system from a security perspective, as well as enhanced Globus support for moving data around, additional imaging support. So lots of good things to kind of see. And again, we continue to support all aspects of clinical research, that whole workflow process, and we'll continue to add new and improved functionality there. So with that, thanks everybody, and have a great Thursday, and we'll talk to you next month.